Good morning. Last class we discussed about definite integrals. Today we discuss application of definite integrals. That is the area under plane curves. In this chapter, first we discuss area of a bounded region. How we can find area of the bounded region. First we discuss a theorem. Let y is equal to f of x is a continuous function defined on closed interval AB. Then the area bounded by the curve y is equal to f of x and the x axis and the abscissa x is equal to a, x is equal to b. In between interval a and b is given by integral x is equal to a to b f of x dx. Here a less than b, okay, or a to b, integral a to b y dx. Here we take a figure, that is the suppose this curve is a y is equal to f of x, that the bounded region x is equal to a, x is equal to b, so the bounded region is that. Okay. Now we take an example from your exercise 10. Okay, from your example exercise 10 number 1 I. Okay, find it. Now the question is find the area, find the area bounded by the curve y is equal to e to the power x, x y is equal to 0, y is equal to 0 means x axis x is equal to 4 and x is equal to 2. Okay, we have to find the area bounded by this curve y is equal to e to the power x and y is equal to 0, that is a x axis, and abscissa x is 2 and x is equal to 4. Okay, answer given curve is y is equal to e to the power x. Hence the required area is equal to, that x is equal to 2, lower 2 and greater 4, so we write a 2 to 4 integral y dx, that equal to integral 2 to 4 e to the power x dx, that equal to e to the power x. You know the integral of e to the power x is e to the power x, that is 2 lower 2 upper 4, that you put upper value e to the power 4 minus e square. Okay, that is the required area bounded by the curve y is equal to e to the power x and x axis and the abscissa x is equal to 2, x is equal to 4. Okay, if the curve lies below the x axis. Okay, now we discuss if the curve lies below the x axis, if the curve y is equal to f of x lies below the x-axis and abscissa is same. X is equal to A and below the x-axis and the abscissa x is equal to A, x is equal to B, and the abscissa x is equal to A, x is equal to B, the abscissa x is equal to A, x is equal to B is negative. Below the x-axis, then the area bounded by the curve y is equal to f of x is negative. Y is equal to f of x is negative. So in this case, required area is given by a to b y dx whole mod, because the area is always positive. Okay, next we discuss along y axis. If the curve lies along x y axis, okay, then theorem. The area bounded by the curve x is equal to f of y, that's the function of y. The area bounded by the curve x is equal to f of y axis, and ordinate y is equal to c, y is equal to d. Okay, the area bounded by the curve x is equal to f of y axis, and ordinate y is equal to c, y is equal to d is given by y is equal to c, y is equal to d, x dy, f of y dy or c to d x dy. Okay, that we represent it in the figure. Suppose this is x is equal to f of y. Here c less than d, that a cover area y is equal to c, y is equal to d, that is the y axis, x axis. So we shaded the cover area, that is A, B, C, D. Okay. Now we take an example from your exercise 10. Exercise 10, number 1, number 2. Number 2, I find the area enclosed by the curve y is equal to e to the power x, x is equal to 0. That means y axis. X is equal to 0, y is equal to 2, y is equal to 3. Okay. Now answer. Given curve is y is equal to e to the power x, hence the required area, that means area bounded by the curve y is equal to e to the power x, x is equal to 0, that is a y axis, and a coordinate 2 to 3, hence the required area that equal to integral 2 to 3 x dy. Here first we find here x, y is equal to e to the power x, taking logarithm on both sides. Ln y is equal to ln e to the power x, that imply ln y is equal to x ln e. You know, ln y is equal to x because ln e is equal to 1. Okay, that integral 2 to 3 ln y dy. Now we integrate ln y by integration by parts, that equal to 2 to 3 integral ln y dy, that is 1 into ln y dy. Here we take first function 1 dy into ln y minus integral 1 dy d by dy of ln y whole dy. Okay, that equal to y ln y minus integral y into 1 by y. You know, derivative of ln y 1 by y dy, that equal to y ln y that equal to y ln y minus integral 1 dy y ln y minus y. Okay, so here we write y ln y minus y 2 to 3, that equal to 3 ln 3 minus 3 minus 2 ln 2 minus 2, that equal to ln 3 cube minus 3 minus ln 2 square plus 2, that equal to ln 3 cube 27 minus ln 4 minus 1, that equal to ln 27 minus of ln 4 minus ln e. You know, the value of ln e is 1. So ln 27 minus of ln 4 minus of ln 4 plus ln e. Using logarithm rule, ln 27 minus ln 4e, that equal to ln 27 divided by 4e. So the required area is covered by the curve y is equal to e to the power x along y axis is in between interval 2 3 is ln 27 divided by 4e. Okay, now we discuss area between two curves. Area bounded between two curves. Area between two curves. Area between two curves. Okay. That is area between two curves. Area between two curves y is equal to f of x. Y is equal to f of x and y is equal to g of x. Y is equal to g of x, where g of x less than f of x. With g of x less than f of x in the interval AB, in closed interval AB, we have to find area between two curves f of x and g of x, where g of x less than f of x in between the interval in the interval A B, closed interval AB, and between the abscissa and between the abscissa along x-axis, abscissa x is equal to A, x is equal to B, x is equal to A, x is equal to B is given by, here we denote area as A, given by A is equal to, capital A is equal to integral A to B f of x dx minus A to B g of x dx. That means area covered by f of x in between interval, in the interval AB, minus area covered by the another function g of x in the closed interval AB. That we write A to B f of x minus g of x whole dx. Okay. Now we take an example from your exercise 10 number 3I. Example exercise 10 number 3I. The question is determine the area. Determine the area. Determine the area within the ellipse. Within the ellipse x square by a square plus y square by b square is equal to 1. Now we find the covered area by the ellipse x square by a square plus y square by b square is equal to 1. Answer. Given ellipse is x square by a square plus y square by b square is equal to 1. X square by a square plus y square by b square is equal to 1. Now we simplify it. X square by a square plus y square by b square is equal to 1. Now a figure that is ellipse. Here x o x dash y o y dash. That if we put y is equal to 0, then we find a point on the x-axis. Here x square by a square is equal to 0. Put y by putting y is equal to 0. So x is equal to plus minus a. Here the point is a0 and it is minus a0. Similarly, if we find the point on the y-axis, we put x is equal to 0. So we get a y square by b square is equal to 1. That is y square is equal to b square. So y is equal to plus minus b. So here 0b, that is 0 minus b. Okay, that is this ellipse is symmetric on both axes, x-axis and y-axis. Now y square by b square, that equal to 1 minus x square by a square, that y square by b square is equal to a square minus x square by a square, that y square is equal to b square by a square whole into a square minus x square, that is y is equal to plus minus b by a root over of a square minus x square. Okay, the given ellipse, we write it, the given ellipse is symmetric about both coordinate axes, Okay, so hence the area of the ellipse is 4 times that the portion lies on first quadrant. Hence the area of the ellipse is 4 times that the portion of the ellipse, or region portion of the ellipse, that means that 4 times of this portion. Okay, that is equal to this. Okay, the portion of the ellipse lies on the first quadrant. Portion of the ellipse in the first quadrant. Okay, portion of the ellipse of the first quadrant. First quadrant bounded by x is equal to 0, that means y-axis, and that axis x is equal to 0 to a. That the quadrant bounded by x is equal to 0, x is equal to a. X is equal to 0 point, also x is equal to 0, y-axis represented. Okay, 0 to a. So 0 to a, and the curve, that is y is equal to, and the curve y is equal to b by a root over of a square minus x square. Root over of a square minus x square. Hence the required area, hence the required area 4 times of x is equal to 0 to x is equal to a y dx along x axis. To find the area covered by the curve y is equal to b by a root over of a square minus x square in between the point a x is equal to 0 to a. So we write 4 times 0 to a y dx. We find the total ellipse area. You know that the total area covered by the ellipse x square by a square plus y square by b square 1 is 4 times of any section. Here we take the first quadrant. In section on the first quadrant. Okay. Now 4 times a to b y dx here that equal to 4 a to b in place of y put b by a root over a square minus x square dx that 4b by a to b root over a square minus x square dx that you know the formula that 4b by you know x by 2 root over of a square minus x square plus a square by 2 sin inverse x by a to b sin inverse x by a, you know. So now put the value of x 0 to a, that is 0 x is equal to 0 to x is equal to a. Here x is equal to 0 to x is equal to a, 0 to a, okay, 0 to a. That is, now put the value of a first, 4b by a first, that becomes 0 plus a square by 2 sin inverse a by a minus, next we put 0, that becomes total 0, that is 4b by a, that into a square by 2 sin inverse 1, that 4b by a into a square by 2 pi by 2, you know sin inverse 1 that equal to pi by 2, that means sin pi by 2 is equal to 1. So here we cancel 4 that remains pi ab. So the area covered by the ellipse x square by a square plus y square by b square is equal to 1 is 4 pi ab. Okay, thank you.